today what I thought I would answer is one of the most common questions that I get asked when I teach about geosynchronous, or also known as geostationary orbits. And that is, why do the satellites need to orbit above the equator on the Earth? In other words, why are they equatorial orbits? Well, let's consider some other scenarios. Let's consider an orbit which is tilted at an angle. So something like this. So it tracks a position in the sky around the Earth. Let's say something like this, at some angle, maybe theta across here. Well, if you imagine that you are an observer, this is not drawn to scale, by the way, but you're an observer on the planet and you're out there trying to look for the satellite. If this satellite is tilted at an angle, even if the orbital period is still 24 hours, then because of the angle of the orbit, the satellite will appear to move with respect to the observer. The same thing will happen if that angle was 90 degrees. In other words, if we had a polar orbit, like so, once again, the satellite will appear to be moving north to south or south to north, depending on the direction of movement of the satellite. So the equatorial orbit is the only possibility in which a satellite will appear stationary with respect to an observer on the Earth, like so. Now, as soon as I make this argument, quite often students would quite rightly so ask, well, why is it that this is the only possibility? Why is it that I cannot, let's say, do an orbit which is around here? So an orbit like so. Let me just draw this once again, actually. So rather than having an equatorial orbit, we can have an orbit which is something like this at a given height. Now the answer is, what actually causes the satellite to move? Well, the force of gravity, which is directed towards the center of the Earth. If you are on the equator, the force of gravity alone will be sufficient to maintain that circular motion. So let's say that we are here, the force of gravity is directed towards the center of the Earth, and this also applies a centripetal force. Now, if we have an orbit such as the one which I've shown here in red, if I'm over here in the satellite, then I'm going to be experiencing a force which is towards the center of the Earth. Now this does not mean that this orbit is not possible. It will still appear fixed in the sky. However, it will require an additional force to maintain that motion. So that means that maybe I'll need some rocket boosters or some propulsion method to apply a force in just the right direction, which will be towards a point centered around there. So this is the reason why this orbit is I'm going to say not possible, but not practical. So a geostationary satellite has to be in a orbit of just above the equator if we're relying on the force of gravity, which of course is the most efficient way of dealing with satellites. Okay folks, so hopefully this clears this up. If there are any questions, please feel free to leave a comment. Thank you very much.